Hello friends, welcome to this video. In this video we will talk about nature of the graph across the root. For that we will take few questions. Let's say we can start with question number 1. Let's say f of x is equals to x square plus 4x minus 12. First of all, we'll find out the roots of this equation. If you don't know how to find out the roots, let's just do it like this way. We will take the third term, and of course we will multiply it with the x square, but yeah, right now we can just take the third term. So you will take the factors of the third term. So 12 factors are, let's say, 1 and 12, 2 and 6, and 3 and 4. So now you will take those factors, so that by adding or subtracting that, you will get the middle term, and by multiplying that you will get the product of the first and the third term. So if you take the first root, so let's say 1 and 12, so when you will add them, so you will get 13 as an answer, and when you will subtract them you will get 11 as an answer, and they both are not making my second term, so I will not take the first root. So let's just go to the second root. So 2 and 6, when you will add them you will get 8, and when you will subtract them you will get 4. Okay, so here I'm getting my second term, so I will take this root. You can check the same with the third also, but right now I have got my root, so I will just take this root. Okay, and of course when you will multiply 6x times 2x, you will get 12x square, okay, which is the product of the first and the third term. But the thing is, here we have negative. Okay, so we're gonna take one of the roots as negative to resolve this problem. Okay, so let's just check here how I'm gonna do it. So here we have x square. I'm gonna take 6x positive minus 2x, okay, minus 12. So now when you will add these two, you will get positive 4x, okay, and when you will multiply you will get negative 12x square as an answer, okay, which is what we wanted. Now I can write this as x plus 6 in the factors form. I'm writing it. So just one thing to note here, that the power of these factors are 1 and 1. Okay, they are occurring like ones and ones. Their powers are 1. Now we will find out it in the form of parts. So for the first part, I will find out when my f of x is equals to 0. So to find out when f of x is equals to 0, I will put these two equals to 0, my factors equals to 0. So these will give me the values when this is f of x is equals to 0. So first, x minus 6 is equals to 0. From here we will get x is equals to negative 6, and then again x minus 2 is equals to 0, x is equals to positive 2 from here. So for these two values of x, my f of x is equals to 0. Okay, when x on the x-axis, when x is equals to negative 6 and x is equals to 2, f of x is 0 there. Now part B, when f of x is greater than 0. To find out when it is greater than 0, let's just plot my function on the x-axis. So let's say if we have, let's say this is my x-axis, okay. So here it's gonna be, if I just draw my quadratic equation, it will be like this, the graph of the quadratic equation is like this. Here, let's say it is negative 6 and it is positive 2. Okay, so these are the points where it is touching the x-axis. Okay, and now when my graph, or wherever this function, this is the function of the f of x. Okay, this is f of x. So when my f of x is above x-axis, it will be positive there, and when f of x is below x-axis, so it will be negative there, right? Okay, like as we take the values of y. Okay, so here of course my y is positive for all these values, or f of x will gonna be positive for all this value, and for all the values below x-axis it will be negative. We are finding right now in this question when f of x is greater than 0 or positive. So for these values, my f of x is greater than 0 for all these values of x, and of course for all these values later on, like after 2, for all these values of x also, my f of x is greater than 0. So I will say that x belongs to negative infinity to negative 6 union 2 to infinity. For all these values of x, my f of x is greater than 0, or I can say that x less than negative 6 or x greater than 2. For all these values of x, my f of x is greater than 0. Now for the part C, what we will find out? When my f of x is less than 0, right? So to find out when f of x is less than 0, we will check, of course, we will check the graph again. So for all these values of x, my f of x is below x-axis, and yes, it will be less than 0. So when my x is between -6, so we will say when x belongs to -6 to 2, for all these values of x, f of x is less than 0, or we can write it this way also, right? Yep. Let's just try one more question. In the second question, we will take our equation, let's say g of x, okay, which is x square plus 8x plus 16. We will find out the factors of this equation also. You can find out the similar way as I just told you in the previous question, but right now I'm just taking the factors directly, which is x plus 4 whole square also I can write, okay? So one thing to note here, that this is occurring with the power 2, okay? This is even power, right? In the last question, it was like power 1 and 1, so this was like the odd power, okay? Yeah. Now, we're gonna find out the three things here again. First part, when g of x is equals to 0, for that, that I will put, my factors equals to 0. So from here, I will get x is equals to -4. Let's try. So x plus 4 whole square is equals to 0, x plus 4 equals to 0, and also x plus 4 equals to 0. X is equals to -4 and x is equals to -4 from here, right? When I will plot this on the number line, I will do it like, let's say this is of course my x-axis. And there will be -4 here. It will gonna touch the x-axis at -4, right? This is, let's say, my g of x, okay? Now for the second part, or part 2, we will find out when g of x is greater than 0. Here we have to find out when g of x is greater than 0. So you can see for all the values of x, this is above x-axis, right? G of x is above x-axis except for -4, because here it is 0. So I can say that for all the values of the r, I can say for all values, right? For all values of x except, we will write here that this is g of x is greater than 0 for all the values of x except x is equals to -4, or we can write it this way, that x belongs to r minus -4 except -4, right? Now we will find out like when this g of x, C part, when g of x is less than 0. So you can see on this graph, like this is above x-axis, before and after -4. So there is no graph. There is no graph below x-axis. So I will say that g of x is less than 0 for no values of x, right? Okay. For no values of x, right? So what we learned from these two questions, that when my graph was occurring with the power 2, okay, with the even power, right? So the nature of the graph across the root remain positive and positive, right? It is above the x-axis, right? So the graph is positive, so the nature of the graph remains same, right? Okay, positive and positive. But when you just saw in the previous question, these roots were occurring with the odd power, so the nature of the graph was changing across the root. So across -6, it is first positive and then negative. Similarly for the 2, it is first negative and then positive. So the nature of the graph changed when the roots were occurring odd number of times, and the nature of the graph was nature of the graph didn't change when the root was occurring even number of times, right? Like as we saw in this question. So let's just write down that two main points we discussed or we got from this discussion, that when root occurs odd number of times, then the sign of the graph changes across the root. And another thing we note from here, that when root occurs even number of times, then the sign of graph remains same across the root, right? Okay, so these are the two things we learned from our discussion, right? So far, on the basis of discussion, let's just try a question. Okay, let's say we have a question. On the basis of this discussion, let's just try a question. Here we have minus 3 raised to power 4, x plus 5 raised to power 7, and 3x minus 11 raised to power 4 less than equals to 0. So we have to find out the roots of this equation first. So the roots of this equation will be x is equals to 3, x is equals to negative 5, and x is equals to 11 by 3. Right, so let's just plot this on the number line. We will get negative 5, 3, and 11 by 3. Okay, let's just check how many times they are occurring. So this is coming 7 with the 7 power. So this is occurring 7. Why I'm just writing this? So just to check if it is occurring odd number of time or even number of time. Then second is occurring, with the power 4, even number of time. And the third one is also occurring with the power 4. Right? Now let's just take a number, to check if, the sign of the graph. So we can take any number before negative 5. Let's just take negative 10. So when you will take negative 10 and you will put into this, into the h of x, you will find out this will be positive, this will be negative, and this will be positive. So this will give you resultant as negative, right? Okay. So that's why the nature of the graph will be negative, or h of x will be negative across this, right? Now, if my root will occurs odd number of times, so as we just learned from here, when the root will occur odd number of times, the sign of the graph will change across that. So that's why if my graph was positive before this, after this my graph, if my graph was negative before this, so it will get positive after that. Similarly, this is, even with the even power. So when we just learned here, when the root occurs even number of times, the sign of the graph remains same across the root. So it will remain same. So that is positive and again the positive, right? Okay. But in this question, they have asked us when my graph is less than equals to 0. So it is equals to 0 at these points, right? Okay. And less than 0 before this. So x, for what values of x, my graph is less than equals to 0. So for the values of x between negative 5 to negative infinity, right? Like this is between negative 5 to negative infinity, union 3 to 11 by 3, right? Okay. So let me just tell you about these brackets also, though this is my answer. This question is done, but let me just tell you about these brackets. So this is called open bracket, open or circular bracket. Okay, so this one is called open or circular bracket, right? And this excludes the value, right? Okay, whatever value is across that, we're going to exclude it. We're not going to take this value. Of course, infinity is kind of a state we cannot reach, so we're going to exclude this value, right? Okay, then the second bracket is square bracket or the closed bracket. This is called square or closed bracket, and this gonna include value. Okay, whatever value is in there, we're gonna include it. So we're gonna include -5. Okay, then the third one is called the curly bracket. This is the curly bracket, and curly bracket will just gonna include only the elements that it talks about. So whatever elements are inside, it's gonna include it. Okay, so we're gonna say that you're gonna include the element, right? Right, so this was about the nature of the graph across the roots. If you guys have any doubts or question, so you can write in the comments, right? Okay, hope you understand this topic. I'll see you in the next video. Bye, take care.